7, 6, 5, 4, 3, 2, 1. Vehicle is pitching downrange.
Booster Raptor, chamber pressure nominal.
Telemetry nominal. We heard the tower is go for catch.
Booster engine cutoff.
The return flag is set for true. So there we go. That is the launch of the SpaceX Starship giant rocket from Texas. We're just over 2 minutes into this launch, and Dr. Megan Argo, Senior Lecturer in Astrophysics at the University of Central Lancashire, is also with us. They have passed what's known as max Q, haven't they, Dr. Argo, which is a critical moment. We're probably now about 5 minutes away from them trying to bring that super heavy back down.
Yeah, that's right. That max Q point is the point of maximum aerodynamic pressure on the rocket. So it's the point where the rocket body itself is undergoing the most physical stress during the flight. So once you get past that, in principle, your rocket shouldn't suffer any issues due to stresses. So yes, then the next step is that they do the hot staging, as he was describing there. What they do is they turn off most of the engines on the super heavy booster, which reduces the thrust, reduces the speed a bit. You simultaneously then light the engines on the Starship itself while it's still attached to the booster, and there's a ring that sort of separates them to let some of that exhaust gas escape so it doesn't damage the top of the super heavy booster, and then the two will physically separate. Once that happens, they can start the preparations for bringing the booster back. So again, there's checks that will need to be done, checks on the launch pad to make sure the launch pad team are happy that it's safe to bring the rocket back and it's going to function as designed. And then also that the booster itself is functioning as intended, as planned, and all the data look like that it's working perfectly.
Let's just explain. It has 33 engines. Now, these are massive engines. I was reading earlier that the thrust is almost 700 times as powerful as an Airbus A320neo plane, which we may have got on to travel. So imagine when you take off in one of those, this is 700 times that thrust.
Yeah, it's pretty impressive. They are fantastic pieces of engineering. A large number of the parts, actually, in each one of these Raptor engines is 3D printed. So again, SpaceX's philosophy of trying to make things reusable and cheap, by 3D printing your rocket parts, or as many of them as you can speed up the production process and again reduce your costs. So again, that was a new innovation that SpaceX managed to do in the design and development phase of putting this rocket together. They're a bit different to aircraft engines. Aircraft engines usually burn kerosene, sort of heavy oil fuel, whereas these are burning methane and liquid oxygen. So it's a very, very different, less dirty kind of fuel. So there's a lot less soot that comes out of the back of these engines compared to what comes out of the back of an aircraft.
And you were talking about the fact that 3D printed parts. This is part of the SpaceX philosophy, isn't it? To try different things, to do things, and things will go wrong, but they learn from it to go forward.
Absolutely, and I gather that they've actually changed the mix that they use in the 3D printer over time as they've evolved the design of these engines. So they are still iterating now. I think SpaceX will never tell you their rocket design is complete. They will always be finding ways to improve what they're doing, improve the construction, improve the materials, improve the design, so that they make it function better, be more reliable, and cheaper if they can.
I probably should say, of course, this is not that environmentally friendly doing space rocket launches.
It's not, no. I mean, even with the cleaner fuel than you're using in aircraft, there is still a fair amount of carbon dioxide that comes out of the back of these rocket engines. So building rockets, launching them is causing environmental issues. The more of them we launch, of course, the more impact we have. It's still small compared to the aviation sector, but with the plans for multiple launches per year of large rockets like this and the number of other companies that are working on similar designs, the space industry is moving forward at quite a rapid rate, and we are looking at many more launches per year than we have in the past. So that is going to become a more significant issue in the future.
Okay, so let's go back to mission control because we can see the Super Heavy coming back down. We should get it hopefully being grabbed in the next couple of minutes. So let's listen in to mission control.
There are 4 hypersonic grid fins. We can see that the landing burn has begun on the Super Heavy booster.
And same pattern, 13 engines will light, gone down to 3 just as we expected. What an incredible view of splashdown that we got today of Super Heavy.
Yeah, I'm sure the buoy cam views will be pretty awesome once again. So we'd like to confirm a water landing once again for the Super Heavy booster. Congrats to the SpaceX team for making that milestone as well. Now, ship continues to look good. We can see that it is, while all of that was happening.
So, Megan, we have not had the chopsticks manoeuvre. They've put it into the water, yes?
Yes, that's what it looked like. So we don't know why that happened. Neither of us were listening to the audio on the feed there, so we don't know exactly why that happened. But as I say, there are numerous points where they could have made the call. So something clearly wasn't right, and something, either a software system, an autonomous software system, or one of the flight controls or the flight director was not happy with what they were seeing and ordered the rocket to go and land in the water instead, which is much safer. Not quite as spectacular, obviously not what we were hoping for, but still, even though they haven't managed to catch it in the tower, they will have a mountain of data collected from the flight of the Super Heavy booster, which they will be able to look at over the next few weeks, figure out what they can change for next time, what they can iterate for the next attempt, so that they can hopefully fix any problems that caused it to not be safe to land on the tower this time.
Yeah, which is interesting. I've got another feed and I can see that Elon Musk is talking to President-elect Donald Trump, who is there watching this. Of course, as you said, and as SpaceX have always said, and I've been reading some of their material, if automated health checks show unacceptable conditions with the Super Heavy or the tower, the booster will default to a trajectory that takes it to a landing burn and a soft splashdown in the Gulf of Mexico, because they say we accept no compromises when it comes to ensuring the safety of the public and our team, and the return would only take place if the conditions were right. And that, I assume, particularly with a president-elect watching this, they absolutely wanted to know that it was going to work before they tried that chopsticks manoeuvre, Dr. Argo.
Definitely, yes. As I say, there are so many issues that could potentially have caused them to make that decision. It could have been that, one of the software systems was not happy. It could have been a flight director. Whatever the cause, I'm sure we will find out the details in due course. SpaceX do talk about these things, whether they talk about it openly or whether it comes out later. We do usually find out the cause of these problems at some point.
But as you say, there will be a lot of data that will be important to the SpaceX team in the future to be able to use that for the next one that they do.
Definitely, all of these spacecraft are covered in sensors, so there will be so much information that the team will be able to go through. There'll be information on how the engines performed, there'll be information on how the systems that actually are controlling the attitude, the position, if you like, and the angle of the rocket as they came back as well. So all of these subsystems have multiple sensors, and all of that data was being sent back in real time to mission control. So they have all of that data, even though the rocket has now landed in the ocean and will presumably sink. So they will be unlikely to recover this rocket. But still, they still have the data.
That is interesting, because the whole point of this is that the rockets are expensive, so they do want to be able to reuse them, as we've said, because Elon Musk wants to be able to do that to get astronauts as part of the NASA program to the moon, and he of course wants to go to Mars. But you're saying that they won't be able to recover any of it out of the Gulf of Mexico.
That's the ultimate aim, but when you're doing these early test flights, you expect to lose hardware. And again, that's what they did in the Falcon 9 development phase as well. The early stages of that, they lost an awful lot of hardware, and that was kind of built into the development plan. They knew they were going to lose various boosters in that testing phase, and they planned for that, they budgeted for that. But every launch tells you something, and that data itself is really valuable. They even said on the early test flights of this rocket, the data is the payload. That's what we want from this test flight. We know something's going to go wrong. It's a matter of how it goes wrong and how we can fix it next time. So the data is the key.
That's where the engines are producing that flame, and then they stop the engines to bring it back down, and it splashes down into, as we can see there, the Gulf of Mexico. The SpaceX control room still doing a large round of applause as that happened. Let's take you back to the live pictures now. Dr. Argo, we've seen what's happened to the Super Heavy, but the top bit of the Starship, the ship, that is still in the air. What happens now with that?
So the Starship is going to take a very similar trajectory to the trajectory of the previous Starship on the previous test flight. So it's going to be in space for the best, well, it's going to be in flight for the best part of an hour in total. And it will go into suborbital space, so it will go above the atmosphere, it will go into space. And there are a few changes compared to the last one. So one of those is to do with the insulation on the spacecraft itself. Insulation is really important if you've got a spacecraft that's going into space and then coming back through the atmosphere. That insulation is largely what protects the spacecraft from the incredible temperatures that you get on re-entry as you pass into the atmosphere, traveling at very, very high speeds. Your rocket gets very, very hot. And if you don't have a good working heat shield, it can do significant damage to the spacecraft and anything in your spacecraft, be that electronics, be it payload, be it humans. So you need to know that your heat shield is functioning correctly. So that's one
And on
change.
that, yeah, it was
Sure.
interesting because on that, SpaceX, they talk about their next test flight, the 7th flight, that they want to use the latest generation of tiles and thermal protection layers because in the end, they want to be able to create a fully reusable heat shield.
Yes, and that's a huge challenge for sending anything to space. If you look at pictures that you can see of space shuttles after they've landed, you can find them on the internet quite easily in NASA's archive. They've got lots of pictures of this. The heat shield is always, when it comes back, pitted and full of holes. So bits of it on that particular design were designed to ablate away. So parts of the heat shield just burned away as it came through re-entry. That is a challenge for reusability because it means that it's a lot longer in terms of how long it takes for you to get your rocket ready for the next launch if you have to replace most of your insulation, most of those heat shield tiles. If you can manufacture tiles that will survive re-entry and survive re-entry intact through all that high temperature environment and on the plasma that you get as you come back through the atmosphere at speed, if you can make tiles that can withstand those conditions, and when they come back, they are capable of going through it again and doing it safely, then again, your reusability, you can potentially turn a rocket round in a few days rather than it taking months to replace all of those tiles. So yes, this is absolutely about that reusability, and again, partly about the cost as well. If you don't have to replace the tiles, brings the time down. If your time is less, you're paying less in terms of manpower, in terms of labor to turn your rocket around.